This question asks us which transition results in the emission of a photon in the ultraviolet, which is 10 to 400 nanometer region of the electromagnetic radiation spectrum. And then we're given transitions from one energy level to another. So you should be given a packet of equations with your exam, and I would definitely find out if you are, because if you're not, you should memorize some of them, because this question is all about which equation to use. And you can notice that we're talking about transitions between energy levels, which is essentially what the Balmer-Rydberg equation is for. And if you can't see that from the problem statement, what you can also do is just list all the variables that you have to be working with. So for example, we know we need to work with lambda because we're checking to see if the emission of a photon is in an ultraviolet region. We know we're working with m, we know we're working with n, our different energy levels. So then you can look at your packet of equations and go straight to the Balmer-Rydberg equation. And that equation is that 1 over lambda equals r times 1 over m squared minus 1 over n squared, where n is always greater than m. So we know that we need to find lambda to answer this question. So I'm just going to rearrange to find lambda by itself. And I get that lambda equals 1 over r times 1 over m squared minus 1 over n squared. And r is just a constant, which equals 1.097 times 10 to the negative 2 inverse nanometers. So to answer this question, it is a bit tedious. We're just going to try each case to see if lambda falls in the correct range. So starting with m equals 2, transitioning to n equals 3, we can just plug into our formula. And we're going to get that we end up with a wavelength of 656.3 nanometers. And this is outside our range. So we can then do it for n equals 3 transitioning to n equals 4. And we have lambda equals 1 over r times 1 over 3 squared minus 1 over 4 squared, which equals 1,875.2 nanometers. And this is also outside our range. The third one that we're going to try is n equals 1 going to n equals 2. And our formula yields a wavelength of 121.54 nanometers. And this does lie in our range. And just to double check our last value, which is corresponding to m equals 4 going to n equals 5, we're going to get a wavelength of 4,051.5 nanometers, and this is outside our range. So we have our answer, which is the transition from n equals 1 to n equals 2, because the emission of a photon is in the ultraviolet region. And I would just double check all my values before I make a decision and circle an answer on the test, just because sometimes I find that all of them work and I'm using the equation incorrectly, plugging in values incorrectly, and I would do that unless you are cramped for time.